All right, good morning.
Good morning.
Okay, thank you, Odie. Is the only person that is having a good morning. Everyone else could just, sit there and cry over spilt frosting on their gluten-free cupcake. All right, properties definite integral. Y'all should already have these notes already. I'm hoping you guys actually are going to attempt something today. All right, good job. Okay, use properties definite integral. Properties 1 through 4 in this section require that a function be integratable. That means I have to do what? Okay, it's basically the same thing, right? So it's the antiderivative, so therefore I should probably be able to, or need to be able to, take a derivative, right? If it's the antiderivative, I would have, okay, so all rules apply that go along with my derivative. Wow, this is like super creepy. I really think, okay. No, but look. My thingy over here is flickering too.
Your mouse?
Yeah.
No, it's not. Yeah, it is. Oh.
Ha!
Yeah. That's the bad one. You shouldn't do math today.
I know. I need an old priest and a young priest. Anyway, holy water. I know. We got a holy cupcake. Yeah. Isn't a holy cupcake just a donut? Thank you for joining us. We've already, yeah. Wow, thank you. Yeah, make sure you put your phone away this time and take out those notes. All right, so anyway, okay, stated two theorems guarantee that a function f is integratable. That the function is continuous on the closed interval is integratable from a over b. Now, if you notice, I have closed, don't I? Yes. It is closed. Okay, so when we took a derivative, right? Okay, so important. Okay, slight difference. All right, a function is bounded on a closed interval from a to b, and at most has a finite number of discontinuities on a to b is integratable over a to b. Function f is bounded on a closed interval. We got that part, right?
Yeah.
What's that mean?
You mean it's like one question to the other, right?
Yeah. Okay. Okay. And has at most a finite number of discontinuities. Can we could remove discontinuities, can't we? Okay, so we should be able to remove a discontinuity, right? Okay. So, and is integratable over a to b. Integral of the sum of the two functions. If two functions f and g are integratable on the closed interval a to b, then it's basically just take the integral of both. Okay, yeah, so, and
I'm going to have C.
all right, so we're going to do this. So antiderivative. So I have bounds, right? So I could break this up. I could actually break it up into two separate integrals. We're going to do a lot of that later on. But at this point, I'm just going to do, it is what it is. So I'm just going to do all of it together. So I could break it up into the integral from 0 to 1 of this minus the integral from 0 to 1 of this. But you know what? Trying to make life easier. What's the antiderivative of x squared? Nope. Yeah, so it's going to turn into x cubed, right? Remember, add the exponent first, right? And then divide by that. Yes? Okay. And minus. Okay. What's the derivative of e to the x? What's the antiderivative of e to the x? Thank you. Minus e to the x, right? Yeah? Okay. And since this is the antiderivative, do a, and this has a, this is definite. This is definite, so it has bounds. Do I need to add c? No, I don't need to add c because I have bounds. Because when I do top minus bottom, the c is always going to go away. So I got my bounds from 0 to 1. So what does that really mean? Someone explain this to me, please. Yeah, that's what I'm looking for. All right, so it's going to be this. So top is going to give me 1/3 minus e to the 1, right? Minus sign, right? Parentheses. And this is super important. Always use parentheses on your second lower bound because you're always going to have to distribute that negative. And I guarantee you that's where a lot of people are going to screw it up. So I'm putting an emphasis. Put the parentheses there. All right, and 0. 0 divided by 3 is?
0.
And minus e to the 0 is?
1.
There we go. So this is 1/3 plus 1, right? Which is going to give me 4/3 minus e. Jess, are we okay? Super. So super. Oh my god. All right, do another one. Integral of a constant times a function. I actually did this one. I did this one the other day, didn't I? I factored out a number. Yeah, factor out a number. If you have a constant thing, make the math easier by factoring out the greatest constant. Notice how I said constant, not variable. Constant. We're going to do some problems that you're going to have a pi in my function. Do you think I want the pi in my function? No. We're going to pull the pi out all the time. And it's going to make the math a whole lot easier. So we know if it's a constant, at the end, I just have to distribute a pi into my answer. Okay? All right. So, is there a constant here? What's my constant?
3.
Just 3, right? So, I'm going to rewrite this as 3 from 1 to e of 1 over x dx. Now, time to use your noodle. What derivative will give me 1 over x? ln. So it's going to be ln x. Very good. So it's going to look like this. It's going to be a 3. I like brackets. Okay? Because it's going to tell me at the end, when I'm done, I'm going to multiply my answer by 3. So it's going to be top minus bottom. So it's going to be ln of x, bam, from 1 to e. We talked about the ln of x the other day when we do the antiderivative or the integration. Why did I put absolute value bars there? Can't be negative, right? Okay, it cannot exist in the negative, right? So even though that I have certain bounds on this already, I'm putting this there. Okay, it is a super good habit. I have a definite integral, and it's from 1 to e. Is that any of that negative? Say no. No, that's not going to be negative. It's all going to be positive. But it is a super good habit right now to start doing it because you will get it wrong later on. Okay? Just get in the habit. Whenever I'm taking the antiderivative, I know that it exists, that I cannot have anything in the negative realm for this. So therefore, I put absolute value bars. When I plug in, it's all going to go away anyway. So top minus the bottom. Top minus the bottom. So 3. And what is the ln of e? 1. ln of e is 1. Okay. Minus the ln of 1. ln of 1. What's ln at 1? I heard it. 0. It's 0. So my answer is going to be just 3. And let's say, for instance, you forgot how to math. Your calculator could do definite integrals to check your answers. No, you know, it's not going to be available on this quiz right here, but once it comes time to take the AP exam, okay, we will have more options for that. use the calculator. It's funny because they've made the calculator part of the AP exam. It's just ugly numbers. You could do it all without a calculator anyway. So that's why I'm training you guys to do everything without a calculator, where when you finally get to use a calculator, it's a tool. It's not a crutch. Okay, don't let it be a crutch. It is a tool to help you check your answers. And in those type of problems that we do have something ugly, then yeah, calculator's helpful. Now, this one right here. I like this one.
Is there a writing part?
Yeah.
The AP?
Yeah, that's the free response. That's the reason why every test I give you has a multiple choice and a free response.
But it's not an essay.
Yeah.
Oh no, what?
Yeah. Why do you think? Yeah, seriously.
Oh,
You have
it's
to like
proof
explain an
essay?
answer and stuff like that.
But it's not like.
No, it's
No,
not.
no, it's not like 5 paragraphs. No. Why would there be? Come on. Anyway,
'Cause
all right.
other
So
AP, there's a essay.
make this easy. What would I do to try and simplify this problem out?
You got a 2. Oh wait, no.
Right there.
And then 3.
Factor by 2 over 2, 1 over 2x. Now put x on top.
You're thinking, it's algebra skills here. Come on.
Yeah, you said it, right?
What are you going to do with it?
Factor by grouping.
Nope. Come on, you guys. Go ahead.
The upside down division.
The only time we need that with synthetic division is there a binomial on the bottom? This is a monomial, right?
Yeah.
So what could I do with every term? I could divide each term individually.
Oh.
Oh, yeah.
I could separate my fractions.
Oh, rather than.
Beautiful. Yes.
Oh,
So if I'm separating my fractions, that's going to be the integral from 1 to 2, right? And separate my fractions. So that's going to be 3 over 2, but one of those x's will cancel, right?
Yep.
So I'm going to get 3 over 2x squared. Okay, now let's do the next one. So that's going to give me a minus 3x. Very good. And separate the next one. Minus 5 over 2. And my last one? Okay, so it's going to be plus 2 over x, and this is still my dx. So I used algebra to simplify this problem. So now I separated each one of these terms. And I'm going to just take the integration of the whole thing. And that's going to make life a whole lot easier. So separate the whole thing. Okay, go ahead. Antiderivative of the first one.
Yeah. Like 2? Maybe no. 9 over 2.
Okay, think of it.
3. Oh wait, no.
Now, what do? What do? Add 1 to your exponent first, right? So always do this. Do your exponent first. So it's x to the third, right? And then it's supposed to be over 3 now. And so it's going to turn into 1/2. Yeah, because you're dividing by 3 and I'm multiplying by 3, so the 3's will cancel. Okay, this next one is going to be minus. Do your variable first. What is it? X squared, right? So do the variables first. Do your exponents first. So I have x squared, so it's going to be 3 over 2 now, right? Very good. What about this next one? Does it have a variable? No, but I need to add 1. So it's going to be minus 5 over 2x. And this last thing right here.
We rewrite it and then we do that.
No.
No? Just 2 up.
To what?
ln.
To ln, right? So it's plus 2 ln of x, right? From 1 to 2. Yeah.
Absolutely.
Yes, thank you. And, There we go. Someone paid attention last time.
I was fighting my
Oh, I'm sorry, I couldn't hear you. I have this ringing in my ear. I don't know what it is. It's weird. Okay. Okay. Anyway, all right. So now I have everything done now, right?
Yep.
Now it's time to start plugging in. So let me see. So top minus bottom. So it's going to be 2 to the third power is going to be 8 divided by 4 is 2, right? 4. It's 4, right? And this is going to be 4 divided by 2 is 2 times 3 is 6. Okay, then it's going to be this one right here, which is going to be minus 5. And that's going to be plus 2 ln of 2, right? There we go. Now top minus the bottom, which is going to give me 1/2 minus 3 over 2 minus 5 over 2. And ln at 1 is 0 times 2. There we go. I'll put plus 0 so we just have a marker there to show what that was. All right, let's go ahead, combine it all together. So everything's going to be over 2. So we're going to have a, what's that going to be? A negative 8 over 2. That is negative 7 over 2, which will make it a positive 7 over 2. So I do still need the over 2 on this one here. So that's going to be, let me see, negative 11 and 4 is negative 7. Yeah. So negative 7, and so that's negative 14 over 2. And then I have my plus 2 ln of 2. So as I put those together, I'm going to have a negative 7 over 2 plus 2 ln of 2. Please, please, double check my math, because I'm just making this stuff up as I go.
Do we have to, expand, do we have to, you know, like, on the test, expand the 2 or do we just keep it as it is?
Expand the what?
I don't know, solve, what's ln of 2?
It's a number.
We don't
It's
have
a
to-
numerical value.
Yeah, we don't have, wait, what?
Yeah, ln2 is a numerical value. Kind of like e to the first power is like 2.7 something.
Yeah.
So you could actually put in the calculator and you'll get a decimal. It's an irrational.
Oh,
Okay, it's irrational. So we just leave it as that. It's kind of like square root of 3. You know, it's a nasty decimal. So it just leave it at square root of 3. Okay. All right, you guys okay with my math here on this? Because like I said, you know, the calculus is easy, but you know, the basic numbers I mess up sometimes. Are we good? Okay. What?
You say the calculus.
What's 6 plus 5?
Calculus is easy, but the numerical stuff is hard.
I wouldn't say hard to type it.
Yeah, that, you know, calculus is easy, but this stuff right here is like, you know,
Yeah.
yeah, just putting basic numbers together. So, anyway. So, and it's your job to question me on all this to make sure that I am getting it right. And so let's see. If a function f is integratable on an interval containing the numbers a, b, and c, then, okay, then we could actually break it up into separate parts. Okay, so let's say for instance, I want it over certain parts. Let's say for instance, so this is a basic way to do this. But normally, you're going to see this. If I want the total of something, we usually have something like this that we're going to have to do from here. We know over here, this is going to give me a positive number, right? So let's call this one A, call this one B, and call this one C. So from A to B is going to be a positive number, right? Say yes. But from B to C would be that would be a negative number, right? So is there a way to find the total area enclosed here without doing a negative? Without getting negative? Because if this is a sine wave, wouldn't it just give me 0? It would give me 0, wouldn't it?
So you just take you take both of them, you separate it, and then absolutely.
And then, what would you do for this bottom piece right here? Is there a way to change this from a negative to a positive? Yes, there is.
If it's distance.
Because we're going to get the total, right?
So you just have to change the sign.
Yeah, we could. Knowingly, right?
Or just multiply A and B with the sign. Just multiply A to B twice.
Do you guys remember that?
Yes.
Oh.
Oh, flip it.
Remember, we could change the bounds. We could change the bounds. So if we change the bounds, right, instead of being the bottom minus the top, right? Or I'm sorry, top minus the bottom, we change it to this to be backwards. And so we would negate it, wouldn't we?
Yeah.
There was a reason for that. And that's why we're actually getting into this now. All right, so f is integrable, closed interval from 2 to 7. Then, I love this. Okay, so we could break it up into separate parts. So we could break it up in from 2 to 4, where this right here might be at 4. We might have a discontinuity or something else that I cannot continue it. So I have to pick it up again at 4, don't I? So that's what I would do. I would pick it up again at 4 going to 7. Right? All of it together. But on this next one right here, if I want to do from 3 to 10, but I start off with 3 to 25, and you notice what they do here.
Oh, you subtract.
They subtracted the bottom half, right? Because they only wanted to 10, right? So this is technically doing, you know, the same thing I just showed you. So now I only want up to 10. So I'd go from 10 on, get rid of all that. Get rid of it by doing it. The bounds are backwards, so therefore it's a minus sign now, right? Yes? Yeah, that's why.
Wait. So you do want us to switch it back? But
You
that's like-
can. Yeah, but you notice the bounds are already backwards there.
Yeah.
The bounds are backwards, so it's already going to be a negative there.
Would you solve it the same?
Yeah, solve it the same though. Because we'd get from 3 to 25, let's say for instance, this area is, you know, 100 units. Whatever it is, it's 100. But I don't want all of it, I only want from 3 to 10. So I'm going to get rid of the rest, which this from here to here is going to be like 70 units. Okay? But because the bounds are backwards, this is a minus 70, isn't it? That would be a minus 70, so my total would be the whole thing minus this one, which would give me a 30 units, right? And that would give me just from there to there. Yeah?
Can we only split it up into 2 parts, or can we do like as many times?
Oh yeah, whatever you need. We actually have some AP questions that are similar to this. Okay, all right, so I am going to leave us off here. Okay, I'm going to leave us off here. We're going to pick this up again tomorrow, and you guys are going to like, share, and subscribe. Hit that notification button, and we're going to do about 20 minutes of work.